Hi everyone. In today's challenge, we are going to solve this problem. The problem name is number of base to reorder array to get the same BST, and the problem number is 1569. Alright guys, so as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. And after that, we are going to move to the implementation part. And today, we are not going to implement with C++ and Java. We are going to implement with only C Python programming language. And the reason is I have tried by using these two programming languages, but it's going to take more than 30 minutes of video, right? So I don't want to make this much long video. So but I make sure that if you understood the logic part and the implementation of Python you have seen, then definitely you can implement in your programming language, whether it could be C++, Java or JavaScript or Ruby, any programming language. But you need to be understand the logic part, right? So that you can easily understand logic and Python implementation in this video, right? So now let's understand this problem statement. What this problem say? So problem say given an array nums that represent a permutation of integer from 1 to n. So we are given first input, that is nums, right? Nums is nothing but an array of integer. And we are going to construct a binary search tree BST by inserting the element of nums in order to into an initially empty BST. Nothing guys, they have telling us that we have a some value, right? If let's say here is 1, 2, 3. So we are gonna make a BST binary search tree from this value in order. See guys, in order. Like first we have 1, so we are gonna take 1. Then we have 2, so we are gonna insert 2. 2 will definitely gonna come right side. 3 also gonna come right side, right? After that, find the number of different way to reorder nums so that the constructed by BST is identical to the that form, we can say from the original array nums. Simple guys, they have told us we have to rearrange or reorder this particular array such that the after reorder we are going to again create a BST. Then that BST should be same the previous one, we can say BST, right? So let's say the initially our array is nothing but like this 213. So guys, if this is 213 and we have constructed the binary system like this, right? This will be the BST of this particular input. Now what we are going to do, we are going to reorder this particular array. So we are going to reorder, let's say I reorder in such a way, this way. So if we have reorder in this way, so what will be the binary system of this? This will be binary system will be like this, 2, 3 will be here, 1 will be here, right? You can see both having a same, right? So that means we can reorder in this way as well because BST remain gonna same. So that's what they have told. We have to reorder this nums array and we have to return the number of ways we can reorder so that the BST remains same. So this was the simple problem, guys, right? So you can see in the written example, return the number of ways to reorder nums such that BST form is identical to the original BST formed from nums. After that, they have told since the answer may be very large, return it modulo 10 raised to 9 plus 7. That means they may be given us an array such that they reorder may be more than 10 raised to 9. So we have to return in the modulus of this one. Fine. Now let's understand the example and see how we are getting output, right? Here we have already seen this example 213 and wait, let me see 213. So guys, we can reorder to which will be the base. They are saying that 213 we can reorder nums to be the 231 which will read the same BST. There are no other ways to reorder nums which will read the same BST. So guys, we have seen, right? This example already we have seen. Here you can see 213, right? So their answer is 1. Why 1? Why not 2? Because 1 is already given by them. So we can only reorder by one time, right? They are not considering this old one as well. So we are going to say the answer is going to be 1, right? Total is 2, but 1 they have already told us. So we have to return extra, which is nothing but 1 only, right? In the example 2, let's understand this. So in the example 2, we have this original BST. Now we have this thing, right? Now we have to reorder in such that the original BST remains same. So they have reordered in this 5 base. If you will try to implement the BST using these arrays, you will get the same BST. So the answer is nothing but 5, right? And see guys, they haven't you included this one. They have excluded this one, right? They haven't used in this 5 BST. So we can say every time we have to remove this particular order, right? Or we can say combination. Now let's see the example 3. So in example 3, we have this array 1, 2, 3. You can see even if we reorder any of the number, even we take 2 later or at the front, that we can say we could not make a BST which will look like same. So we are going to say answer is going to be 0. So I hope guys now you understood the problem. Now let's move to the logic part quickly, right? So logic is the important in this problem as this is a hard problem. But believe me guys, logic is also going to be remain same. It is going to be really easy, but yeah, quite hard to implement. So the first thing is guys, what we have to do, we are going to understand the logic part with this example too, because this have a good example having a 5 possibilities. So we'll understood how these possibilities also coming, right? So let me implement this first of all. 3, 1, 4 and 5. Let me write here 4, not 9, 4, 5 and 2. right? This is the array. We can say BST not array, and array is nothing but 3, 4, 5, 1, 2. Now, guys, can you tell me one thing? If we remove 3, this if we don't remove leave out remote, we can say now, if we change this 3 to any of the position, if we take this particular 3 from the first position, if we insert any of the position, will this make sense? If we this particular 3, if I say I am removing this, I'm just putting here 4 instead of 3, and after that I'm writing the same order, will this make sense? Because the first, we can say, the element is always going to be root, right? So you can't remove the first element, right? You can't remove the first element because it always going to be your root. So here you can say if you change any of the we can say value with 3, then that will come at the top, and which will we can say our, which will make our BST different from the previous one, right? So we want 3 should become here only. So we can say we can't remove, or we can't, we can say change this particular first position, right? So we have to change the other position. Now, guys, what position we can change? See, if we have this example, right? So if you will see 3, 4, 5, 1, 2, right? If we say 1 and 2 are coming on this side, 4 and 5 are coming on this side, right? So I can say initially they are taking 4 and 5, right? They are doing like this, then they are taking 1 and 2, right? uh, right. But if I say don't take 4 and 5 first time, take a 1 and 2 first time, then do this. I mean by saying that take first 1, then 2, then 4, then 5. Still they're gonna be same, right? So what you can see, guys, here the left and right side are changing, right? Only left and right, not a, we can say root, not a node, right? The left part and right part, this is changing, right? So can't we say that, guys, the number of ways for this is going to be nothing but we can say the number of left part is going to change, number of right part is going to change. If you still are not getting, so let's understand this with example. uh, Here I am saying that you can also 3, 4, 5, 1 and 2. So it was initially it was this, so after that I can say just put 1 and 2 ahead, 4 and 5 2 later, then after say I can say 3, you can put 1 and 4 in front, after the 2 and 5, because if you will say 1 and 4, then 2 and 5. So if I do like this, so I need to find just how many ways I can do this, right? So I can say total value I am having 4, right? Find out the combination of 4 in with the 2. Why 2? Because total less value I am having a 2. 1 and the less value means the value which is having a less than this root value, means 1 and 2 are less than 3, right? So you have to find a combination of this, which will be nothing but result is going to be nothing but 6, right? And then after that, what we have to do, we have find the possibilities of this, right? We have find the possibilities with this particular thing, that how this can be changed. This can be changed into 6 way, right? It's still gonna give us answer 6, but we have to also go for the left side and right side. Now we have check for this 3 root. From this 3 root we can travel, we can make our we can say this particular array 6 times, right? We can make change our array to 6 times, because we have checked with 3. Now we have to check with 1, then we have to check with 4, then we have to check this 2, then we have to check with 5 as well, and we have to keep multiplying with that possibilities as well. I know it's quite hard to understand, but just one thing I want to say here, that we have to first of all check with root that how many base we can reorder our array such that BST remains same. So I found out that there total are 4 values, means left and right side. Total are there 4 nodes which is present on left, which is present on left and right side. After that, I found out that just tell me the combination with this particular tool, means this particular left side, right? So this is going to return 6. That means I can make our this original array to 6 times, right? So this 4, 3, 4, 5, 1, 2 can be reordered in 6 way, such that it also going to give us VST same. Now I have checked for 3, right? What I have to check for 1 and 2 and 5 as well, and whatever the value they are going to return, that I have to add in this also, and whatever the value this 4 is going to return, that I have to add in this one as well, right? And also this one also, and then will go to their children, then 4 this also going to children, and this will keep going on until and unless you reach to the leaf node, right? And here, guys, I have to if you will notice over here, if I come to this one now, there is only 2 elements, right? So we can simply say if there is 2 elements, so we have to return only one. I hope you are getting it. If there's only 2 elements, so what we have to do, we have to return only one. Are you getting this, guys? If there is only 2 elements, so we have to return only one. If there is here also two because elements, so we have to return one, because we can't change it. If this is 1 and 2, so can you make it like this, 1 and 2, 2 and 1, right? You can't do this, like order is going to remain changed, so we have to going to return 1. I hope this makes sense, right? So that was the things, guys, we have seen, like how we can do this. First of all, we have to find the combinations with this left and rights. After that, we will move to this. Uh, After that, we have to move to this side and this sides. Then we will move to again their childrens, and we have to just keep multiplying there also possibilities into our main result, and we have to return that particular thing. And it's hard to see, and I know it's hard to understand this as well. So, but don't worry, we are going to move to the implementation part with Python, and there you will understand how we are going to implement this logic, right? So guys, first of all, I'm with Python, and here guys, what I'm going to do, first of all, let me increase the size. Here, first of all, what I'm going to do, I'm going to say make a function define sort, and here I'm going to say take a nums array. First of all, I'm going to check it. If length of nums less than or equal to 2, then directly return 1. But if it is not the case, so find out how many numbers are on left side and how many are for right side. So we are going to say for left is going to be nothing but we can say value, for value in nums, if value is less than nums of right, nums of 0 is root, right? Right is going to be equal to value, right side is going to be nothing but value, for value in nums if value is greater than nums of 0, right? After that, once we found the left and right, we are going to say find out the combination which is inbuilt function com, and here left plus right, no, this is not we are going to do. We are going to say find the length, right? We are going to say tell me the left plus tell me the length of right, and here after that we are going to use the length of left. And once we find a combination with this, we're going to multiply with the recursive part, means on the left side and right side. So we can say recursive part with the left side. So how can I do? I can just call a function left side, and also I can call function for right side. Right. Once you have done this thing, you are going to say call this function sol, and here you have to pass your nums array. Now you will say me that is it fine or not, right? Because I have seen some mistake, like 10 raised 1 10 into 9 plus 7. I find some mistake here. Is it fine or not if I do just return this thing? Just tell me one thing. No, it is not fine. Why? Because we are not excluding that particular, we can say, order which we have already given. We have to minus 2 minus 1, which means we don't want to take it, right? And the same thing which you will understand over here, that we were saying here 1 and 2, right? There's only one possible way, right? Right. That's why we are returning a 1. Here we will returning a 1 because if there is only two elements, so return 1 because there is only one pair which we have already we can say considering, right? So if there is a 3 pair was if 1 2 3, or we can say like this thing 2 1 3, so we can say now just do calculate for two root. But if there's only two nodes, don't check it because there's already gonna be only one possibilities, so don't ever waste your time to calculate that particular part, right? So we are going to make this particular as a base condition. Right, now once this is done, we are gonna run this code. We are gonna see whether it's working fine or not, or do we have any mistake. So yeah, we have any mistake, and that is runtime error, and that is nothing but we could say it's supporting a runtime where we are using a runtime. Alright, so we are not returning that particular thing, right? We have to return. Now let's run this. And guys, you can see that all the test case passed. Let's try to submit this code, and I hope it will get submitted. So you guys can see that we have implemented this logic with Python, and I haven't not implemented with C++ and Java. Again, I'm saying the reason is nothing but the length of video because it's gonna take a long code. Python is easy to use it, right? But for C++ and Java, I have to write a code for writing a combinations. I have to use the combinations as well as there's gonna take at least a 30-minute of video, right? And for that, if you understood the logic part now, you can easily implement with the Python, C++, Java, or JavaScript, or Ruby, any programming language, right? So guys, if you understood the logic part, implementation part, and this we can say a problem understanding part, so do like the videos. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. And if you have any kind of doubt in the any of the part, you can still write in the comment section. I'm always there to help you, right? So thank you.